This is going to be 36-2, solving trig equations. And we're going to solve trig equations and use identities to kind of help us solve them. Now just remember some of the strategies that we talked about yesterday. Cosine and sine have that period of 2 pi. Tangent has the period of pi. And we're going to convert secant and cosecant into cosine and sine, or cotangent into tangent, to help us, just because those values, it's easier to look at what's on the unit circle. So our first one, 3 sine cubed x equals sine squared x. So solving for this, I can subtract sine squared x on both sides. So I get 3 sine cubed x minus sine squared x. This equals 0. And so now solving for this, what I can do is I can factor. So I get sine cubed x times 3 sine x minus 1 equals 0. And so now I have sine squared x equals 0. And I have 3 sine of x minus 1 equals 0. Square root both sides here. Sine of x equals 0. And so now where my sine is going to be 0, so if I take the sine inverse to both sides, it's at 0, and we're going to do degrees. I know it says 0 and 2 pi radians, but I'm going to do 0 and 360 degrees because this is not going to be a value on the unit circle. So 0 degrees and 180 degrees. Now because these are going to be cyclic by pi, I can actually combine it together. Instead of saying 0 plus 360k or 180 plus 360k, I can combine them together, and I can say x equals 0 degrees plus 180k. Now this next one, if I add 1 to both sides, divide both sides by 3, I get the sine of x equals 1/3. So x equals the sine inverse of 1/3. Now that right there, I have to use my calculator for it. Now entering that in my calculator, you're going to get x equals 19.47 degrees. That's what your calculator is going to say. But now we have to examine where on the unit circle that is. Well, that right there, that's 19.47. So then over here, that's 19.47. So the rotation that we're looking for is this rotation here. So I have to do 180 minus 19.47. And so that's going to also give me 160 degrees. So that means each of these is going to be 19.47 plus 360k and 160.53 plus 360k. So these are going to be all possible solutions. And so now I have to find the values between 0 and 360. So I'm going to set k equals 0. And you have to plug 0 for k into each of these. Now if I did that, I'm going to get 0, 19.47, and 160.53. Well, those are all between 0 and 360, so that's good. And then if I plug in k equals 1, it's only going to work on this problem here. So I get 180 degrees. If I plug in 1 here, that doesn't work. If I plug in 1 here, that doesn't work because I get a value outside 360. If I plug in k equals 2, that's going to give me 360 here, but it's parentheses here. So because it's parentheses, you don't include that as your final answer, so those values are too big. And so those are my solutions that I have there. For this one here, secant squared x equals tangent x plus 3. This one we're going to have to use identities to help us. This secant here, I have to think, okay, well, is there any way that I can make it into tangent, or is there any way that I can make a tangent into secant? Well, in this case, I can't make a tangent into secant, but I can make that secant squared into tangent, and so secant squared is 1 plus tangent squared x. And so this still equals tangent x plus 3. Now you bring everything to one side, so I have tangent squared x minus tangent x, and then minus 2 equals 0. And so then both of these, this will get factored. And so I'm going to get tangent x, there'll be 2, tangent x, and that'll be 1. And so this will be a -2 and a +1 equals 0. And so I set each one of these equal to 0. And so tangent x equals 2, tangent x equals -1. So x would equal tangent inverse of 2, tangent x equals, that'd be x equals tangent inverse of -1. So this first one we have to enter in our calculator. So tangent inverse of 2, so that's going to give me x equals 63.43 degrees, and this will be plus 180k because it's cyclic by 180. Tangent has that natural period of pi, or 180 degrees. And then this next one, this would be 135 degrees plus 180k. And then, of course, now to actually find the values, you have to plug in values for k, etc., to be able to find those. For this next one here, same idea. This cosine of 2x, this is x. I have to try and find some way to make the angle either both 2x. I don't know how to just take a cosine x and turn it into that, but I do know how to turn a cosine of 2x, that's a double angle identity, into something else to be able to manipulate it. And so I'm going to have to take this cosine of 2x and turn that into 2 cosine squared x minus 1. Now if you're wondering why did I use that version of the identity, and the answer is, well, if I use something with sine, now I have to start thinking about, well, how do I make them all the same, because I can't make sine and cosine together. And so you'd have to spend this extra step to do that, and so this one, I don't have to do that. Now bringing everything to one side, so if I minus 3 cosine x, if I add 2, I'm going to get 2 cosine squared x minus 3 cosine x and plus 1. And so this will factor. 2 cosine x there, cosine x here, 1 and 1. And so they're both minus. Now because when I solve for this, I have to set each one of these equal to 0. That means x is going to equal cosine inverse of 1/2, and this one will be x equals cosine inverse of 1. And so you'd have to continue plugging values. Now just remember, you do have to do the plus 2 pi k, plus 2 pi k once you find the angles for that. You can't forget that. And then plug in the values for k equals 0, 1, and 2, etc. This one here, if I use my double angle identity, sine of 2x is 2 cosine x sine x. So if I subtract the cosine on both sides, I'm going to get 2 cosine x sine x minus radical 3 cosine x. This does equal 0. And so factoring out a cosine x, I'm going to have 2 sine x minus radical 3 equals 0. And so I have to set each one of these equal to 0. And then solve for each one. And remember, you have to do the plus 2 pi k, etc. Now for this last one, I know this one seems a little confusing, but this is actually a sum and difference identity. This is actually the sine of alpha plus beta. And so if we recognize that that's my alpha and that's my beta, I can now say that this turns into the sine of x plus x over 2. And so this will become the sine of 3 over 2x equals 1. And then take the sine inverse to both sides and solve from there. Now just remember, when I do have that 3/2 x, the sine inverse of 1, that's going to be pi halves plus 2 pi k. You do have to multiply everything by 2 and divide by 3. So multiply everything by 2 and dividing by 3, I get x equals 2/3 times that pi halves plus the 2/3 times the 2 pi k. So just remember, when you go through simplifying that, x would equal pi thirds plus 4 pi k thirds. And then where k is an integer, and then you have to start plugging in values for k equals 0, for 1, 2, etc. Well, this concludes our lesson. If you guys have any other questions, please leave them in the comments.